Hi, greetings to all of you. Today we are going to see about the classical time series forecasting methods which are very useful for you in selecting the right forecasting algorithm. Machine learning methods can be used for classification and forecasting on time series problems. Before exploring machine learning methods for time series, it is a good idea to ensure you have exhausted classical linear time series forecasting methods. You will discover a suite of classical methods for time series forecasting that you can test on your forecasting problem prior to exploring to machine learning methods. Okay, let's move into the types. The first one is autoregression. Autoregression, which is shortly called as AR method, models the next step in the sequence as a linear function of the observations at prior time steps. The notion for the models involved specifying the order of model P as a parameter to the AR function. Example, AR of P. For example, AR of 1 is the first order autoregression model. The second one is moving average. The moving average MA method models the next step in the sequence as a linear function of the residual errors from a mean process at prior time steps. A moving average model is different from calculating the moving average of the time series. The notion for the model involves specifying the order of the model Q as a parameter to the MA function. Example, MA of Q. For example, MA of 1 is a first order moving average model. The next one is autoregressive moving average, that is ARMA. Autoregressive moving average method models the next step in the sequence as a linear function of the observations and the residual errors at prior time steps. It combines both autoregression and moving average models. The notion of the model involves a specific order of the for the AR of P and MA of Q models as a parameter to the ARMA function. Example, ARMA P of Q, P, Q and ARIMA model can be used to develop AR and MA models. Autoregressive integrated moving average. This is nothing but ARIMA. Autoregressive integrated moving average method models the next step in the sequence as a linear function of the different observations and residual errors at prior time steps. It combines both autoregression AR and moving average MA models as well as differencing pre-processing step of the sequence to make the sequence stationary called integration 1. Seasonal autoregressive integrated moving average, that is shortly called as SARIMA, that is SARIMA. So this is also a type of ARIMA model. So this method is suitable for univariate time series with the trend or seasonal components. The next one is vector autoregression, that is VAR. The vector autoregression VAR method models the next time series in each time series using an AR model. It is a generalization of AR to multiple parallel time series, example multivariate time series. So whenever you want to forecast a model with respect to different independent variables, then you can make use of VAR. So this is also called as multiple parallel time series method. So for example, if you want to forecast the CPU utilization, then memory usage as well as the speed of the computer at the same time, then you can use this VAR function. Then the next method is simple exponential smoothing. The simple exponential smoothing method models the next time step as a simply exponentially weighted linear function of the observations at prior time steps. This method is suitable for univariate time series without trend and seasonal components. So if you are having any trend or seasonal components, then you should not use this. And if your data is having a stationary pattern in your time steps, then you can make use of this simple exponential smoothing forecasting method. Then Hall-to-Ilter's exponential smoothing. Hall-to-Ilter's exponential smoothing, HWES, also called the triple exponential smoothing method, models the next time series as an exponentially weighted linear function of the observations as period time steps taking trends and seasonality into account. So in this case, if you want to make use of exponential smoothing forecasting for seasonal and trend components means you can make use of this HWS, Hall to Winters exponential smoothing. The next one is vector autoregression moving average, that is shortly called as Varma. The vector autoregression moving average method models the next step in each time series using ARMA model. It is a generalization of ARMA to multiple parallel series, example multivariate time series. The notion of the model involves the specific order of for the AR of P and MA of Q models as a parameters to the Varma function, example Varma of P, Q. A of Varma model can also be used to develop VAR and VMA models. This method is suitable for multivariate time series without trend and seasonal components. So, the previously mentioned types of forecasting algorithms are the ones which are classically used throughout time series forecasting. So, you can choose the right one for your data if your data is having trend or season or else pattern in it. So, choose the right one and do the correct forecasting. So, I hope this video would be helpful to you in selecting the type of forecasting algorithm for your particular business problem. Thank you. Take care. I will meet you in next video.